in the terms. Okay, what are the both poles? 1 by 4 and 1 by 2. This is the diagram. Okay, 1 by 4 and 1 by 2. Okay, here considering is less than 1 by 4. So shaded path is this one. Okay, so shaded path is inside. That means it is let it be right side. Okay, let it be right side. So 1 by 4 and 1 by 2 is in at the place of right side part of the shaded path. Okay, right side path, that is this path. 1 by 4, 1 by 4 and 1 by 2 is right side. So right side means anti-casual. Okay, right side means anti-casual. So both terms should have changes. Both terms should be changed. Okay, now both terms should be changed. So this term is, this is the standard term. This is minus, and u of n is u of minus n minus 1. Okay, here u of minus n minus 1. Okay, in Laplace transformation, u of t is placed with u of minus t, but here u of n is placed with minus n minus 1. Here also changing, minus of minus plus u of n is changed with u of minus n minus 1. Okay, now here 1 by 4 and 1 by 2. 1 by 4 lies inner part. Okay, see here 1 by 4 lies inner part, that is left side. 1 by 2 lies on right side, that is outer part. So 1 by 4 has no change, 1 by 2 has changed. 1 by 4 is casual, 1 by 2 is anti-casual. So this term has changes and this term has not changes. Okay, so here 1 by 4 lies on inner part, hence no change. 1 by 4, 1 by 2 lies on outer part, hence change. Okay, so for the standard 1 by 4, 1 by 4 means this one, this has to be changed. This has no change. Okay, 1 by 4 has no change and 1 by 2 has change, minus. So this is the standard, this is the change, minus 1 by 2 whole power and u of minus n minus 1. This has no change. Okay, now see for the first condition. What is the first condition? So no changes in the casual. Why there is no changes in casual? Let us see. What is the condition here? Greater than 1 by 2. Okay, here greater than 1 by 2. So this portion outside this circle is the portion. So when our comparing with this shaded path, this 1 by 2 lies on the left side. Okay, 1 by 4 and 1 by 2 lies on the left side, but 1 by 4 we are not taking consideration to 1 by 4. Here we are taking only consideration 1 by 2. So 1 by 2 is left side. Left side means casual. Okay, so no change. Okay, right side means anti-casual, you have to change. Okay, got it? This is the ROC. Up to here, 9th model is completed, and final model, model 10. Model 10 is completely on partial fractions. Partial fractions. These partial fractions has two types. Already we know in every problem we have a go through it. One is proper fraction. And next one is improper fraction. Writing రావట్లేదు ఏమనుకోవద్దని. Okay, improper fraction. Proper fraction means s power 1 by s square. This is proper fraction. Improper fraction means s square by s square or s cube by s square. This is improper fraction. So for improper fraction, make it proper. Okay, make it proper. How? By division. Okay, by division we make it as a proper fraction and do the procedure and apply the partial fractions. Okay, here we have partial fraction, different types of partial fractions. A by, see here, different types of partial fractions. S by s minus 1, s minus 2. Why I am taking only s? Because partial fractions will be applied in Laplace transformation, Fourier transformation. Okay, I will write in order. Partial fractions can be applied in Fourier transformation, Laplace transformation, and jet transformation. Most probably we apply for Laplace transformation and Fourier transformation. Okay, In exam point of view, maximum problems are given in Fourier transform, Laplace transform regarding partial fractions. Okay. In inverse Laplace transformation, these partial fractions are very, very important. Okay. Very, very important. Inverse Laplace transformation, these partial fractions are very, very important because particularly they given problem regarding inverse Laplace transformation, that too improper fraction. Okay, they will give one improper fraction in inverse Laplace transformation, and you have to find the proper fraction and apply partial fractions and find the Laplace transformation. That is inverse Laplace transformation. Okay, that's why I am taking s by s minus 1, s minus 2. Okay, so this can be written as a by s minus 1 plus b by s minus 2. Okay, this is the first method. Second method is s by s minus 1 into s square plus 2s plus 2. So the factors cannot be done. Okay, the factors cannot be done. So a by s minus 1 plus bs by c. Okay, bs by c, s square plus 2s plus 2. This is the second method. These all are proper fraction only. Okay, because here 1 2, here 1 3. Okay, proper fraction only. Now next one is s by s minus 1 into s minus 2 whole square. Okay, this can be written as a by s minus 1 plus b by s minus 2 plus c by s minus 2 whole square. Okay, this is the third problem. This is the third method. Maximum, these are the methods. Okay, now fourth one. This is improper fraction. Improper fraction. Improper fraction, s square plus 3s plus 7, s square plus 2s plus 5. Okay, we have s square and s square, s square and s square. So it is improper fraction, make it proper fraction and find the values. Okay, so some problems are given. See here. Here, numerator is s power 1, denominator is s power 2. So it is improper, this is proper fraction. Here, s power 1, s cube. So it is proper fraction. This is a proper fraction, this is a proper fraction. So see here, s power 1, s square. So it is proper fraction. Okay, just you have to mention whether it is proper fraction or not. You need not to write all these kinds. Okay, so you have to write given question, given is a given x of s is a proper fraction. So we can apply partial fractions. Given is a given x of s is a proper fraction. Apply partial fractions. Okay. So for this one, what are the factors? Factors s plus 2, s plus 3. Okay, s plus 2, s plus 3. So s plus 4 by this one, a by s plus 2 plus b by s plus 3. Already we know. Okay, for a, we have to substitute s is equal to minus 2. So s plus 2 is equal to 0, s is equal to minus 2. Okay, for a, we have to hide this term. Hide this term. So s plus 2 is taken, removed, s plus 4 by s plus 3, s plus 4 by s plus 3. So s is equal to minus 2. Substitute the value, we got s is equal to 2. Next, for this one, we have to, for a, for b, s plus 3. So hide this one, s plus 3 is removed, s plus 4 by s plus 2, s plus 4 by s plus 2, s is equal to minus 3. Okay, that is minus 4, minus 1. So 2 by s plus 2 minus 1 by s plus 3. Apply inverse Laplace. Already we know this formula. Always this formula is coming. Okay, no problem. So here plus 2 means minus 2. E power minus 2 u of t. Here plus 3. Plus 3 means minus 3. E power minus 3t u of t. So 2 into e power minus 2t u of t minus e power minus 3t u of t. Okay. Next, for this one, factors. Find the factors. S plus 2, s square plus 2s plus 3. This is also a proper fraction. Okay. Take partial fractions. Take partial fractions. Okay. Here, S square plus 2s plus 2 has a no factors. Okay, that means no real factors. Imaginary factors are coming. So let that be same function, that is same term. Okay, so with this term, this is the type 2. Okay, this is the model 2, type 2. So a by s plus 2 plus bs plus c, bs plus c. See here, bs plus c, s square plus 2s plus 2. These kind of things, one substitution is we can substitute s is equal to 0. Okay, we can substitute s is equal to 0. Okay, for a, s is equal to minus 2. Okay, s plus 2 is equal to 0, s is equal to minus 2. Okay, s plus 2, s plus 2, s plus 2 get cancelled, remaining s plus 1 by s square plus 2s. Okay, so substitute, we have this a value. Okay, for b value, we have to take this total equation. Okay, better to write in exam like this. Okay, total term and partial fractions term is equal to one equation, so that we can write on substituting the value. Okay, so put s is equal to 0, put s is equal to 0 in total equation. Okay, put s is equal to 0 and a is equal to, already we know, minus 1 by 2 in equation 1. Equation 1 means total equation, that is LHS and RHS. So that is 0 plus 1, 0 plus 2, 0, 0, 2. Okay, minus, already we know this is minus 1 by 2, minus 1 by 2, 0 plus 2. See here, when putting s is equal to 0, b also will become 0. Okay, that is the advantage here. Okay, so plus c 0, 0, 2. Now substitute c value. Okay, now take a same equation and substitute a value, c value. Okay, a value, c value, and compare left hand side terms and right hand side terms. There is no substitution for s. Okay, so here put a is equal to minus 1 by 2, c is equal to 1 in equation and compare s terms. Okay, so denominator get cancelled, remaining is s plus 1. So minus 1 by 2, bs plus 1, s plus 2. So on compare s square terms, s terms and constants. Okay, now comparing s square terms. In left hand side, there is no s square term, so 0. Okay, in right hand side, s square quotient is minus 1 by 2. Here s square quotient is b. b minus 1 by 2 plus b is equal to 0. So b is equal to 1 by 2. Okay, like this, we have to calculate a partial fractions. Next improper fractions. Okay, this is the example for improper fraction. S square, s square. So it is improper fraction. Numerator degree is greater than denominator. This is improper fraction. To make it, we have to write like this. To make it proper, divide with the denominator. So denominator this side, numerator this side. Okay, always it is 1 or 2. 1 s square equal. No? So 1 time is enough. S square plus 3s plus 2. This is 2s minus 1. So 1 plus 2s minus 1 s square. This is the formula. Okay, this is the formula. First reminder. Okay, so here this is the reminder. Okay, so sorry, this is the reminder. This is the quotient. This is the divisor, and this is the dividend. Okay, let it be P Q R S. P, this is Q, P Q S. Okay, so the formula is S plus R by S plus R by P. Okay, S plus R by P. Q is equal to. Okay, this is the formula. So whatever may be the term here, 1 or 2, this will comes first. Okay, next remainder by denominator. Okay, so now take this term and apply. This is a proper fraction. Apply partial fraction to this one. A by s plus 1. What are the factors? S plus 1, s plus 2. So a by s plus 1 plus b by s plus 2. Apply the partial fraction. This is the method 1. Okay. Here we have values. Here we have method 1 values 1 minus 3 by s plus 1 plus 5 by s plus 2. Okay. For this one, what is the inverse Laplace transform? Plus 1 means minus 3 e power minus 1 minus t u of t plus 5 e power minus 2t u of t. This is a 1. Okay. For inverse Laplace of 1 is delta of t. Delta of t. Okay. This is the type 3. That is s square. Okay. This is the type 3 in partial fractions. Okay, proper fractions. Okay, this is the proper fraction, but we have s plus 1 whole square. Okay, s plus 1 whole square. This can be written as a by s plus 1, s plus 1. Next to b by s plus 1, sorry, a by s plus 2, a by s plus 2 plus b by s plus 1. And these has two times. So first term is s plus 1, second time is s plus 1 whole square. If it is cube, you have to write third term also s plus 1 whole cube. Okay, so here we have two times, so you have to write two times s plus 1 and s plus 1 whole square. Okay, for a no problem, directly you can substitute s is equal to minus 2. Okay, s is equal to minus 2 in main value and substitute the value and find this value. For s is for a, we can't find this value s plus 1. Okay, for b value you can't find because s plus 1 square. You have to take greater value, so it is square. If it is cube, you have to take cube. Okay, so s plus 1 whole square is the greater value than this one, so you have to consider this one. So for c put s plus 1 whole square is equal to 0, s plus 1 is equal to 0, s is equal to minus 1. So substitute this value. Okay, this s plus 1 square get cancelled. What is the remaining term? 2s square plus 5s plus 5, s plus 5. Okay, put s is equal to minus 1. Now this is the value. Now we have to take this total. Already I told you have to write main equation and a partial fractions equation in one equation. Okay, this is the main point. So that this is equation 1. Next is very easy. Okay, now substitute the values of a and c in equation 1. Okay, and compare. Okay, here no possibility of s is equal to 0. There is no possibility of s is equal to 0. Okay, so we have to compare. On comparison, now compare s square coefficients, s coefficients and constant. Okay, left hand side and right hand side. In left hand side 3s square 3, 3s square 3 and bs square. So 3 plus b is equal to right hand side 2. B is equal to minus 1. So this is the value 3 by s plus 1 minus 1 by s plus 2 minus s plus 1 plus 2 by s plus 1 whole square. Okay, now apply the inverse Laplace. Already we know 1 by s plus 1 is e power minus at u of t. So already you are observing every time this formula is coming either in the forward direction or reverse direction. Okay, so in Fourier transform or Laplace transform, this is the only formula repeating every time. Okay, in continuous. In discrete, another formula is there, that will be continued. Okay, so for this one 3 e power minus 2t u of t minus e power minus t u of t plus 2, here square is there. For s plus 1 it is e power minus t u of t. For s plus 1 whole square means t, whole cube means t square, whole power 4 means t power 4, that like. Okay, so t power n e power minus at u of t. Okay, this is one of the important formula for n time. Okay, first of all, for n, you have to write n factorial. This is very important. Okay, n factorial s power n plus 1. Okay, sorry, s plus a. Here, this term is there, no? For minus a, it is plus a whole power n plus 1. Okay, suppose it is t cube e power minus 2t u of t. Okay, now e power minus 2t s plus 2. Okay, this is completed. For u of t, 1. Okay, completed. For t cube, you have to write 3 factorial whole power, okay, 3 plus 1. Now 3 factorial means 3 into 2, 6. 6 by s plus 2 whole power 4. Okay, this is one of the important formula. This is also important formula. Only 10% this formula will become 90% this formula. This is 90% formula. Okay, so it is completed. And unit 3 important questions. These are the unit 3 important questions. Okay, just I am skipping this one. Already you have material. For this material, from the material you study these questions. Almost all questions are there. Unit 3 part 1. Okay, pass this one and prepare it. In Fourier series, part 3. Okay, unit 3 part 1, you have a Fourier series. In Fourier series, properties are very important. Okay, properties are very important. After properties, Fourier series, that is trigonometric, that is this one. Okay, this one, if anything is not said, so you have to take trigonometric Fourier series. You have to calculate a0, an, bn. Okay, and substitute in this value. Another important is this one. Okay, when k is equal to 0, this one. When k is equal to 1, this one. When k is equal to 2, this one. When k is equal to 3, this one. When k is equal to 4, this one. Okay, so you have to sin omega t. For sin omega t, write the formula and find this is the main standard equation. For Fourier series, this is the main standard equation. Compare these coefficients with these coefficients. Okay, on comparison, you will get values. Okay, here k is equal to 1, so minus 1, 0, plus 1. If k is equal to 2, minus 2, minus 1, 0, 1, 2. Okay, these are the important models. If we ask about spectrum, this is the spectrum. Okay, at a time he will ask 4 questions like this: A, B, C, D. Okay, trigonometric Fourier series. Okay, exponential Fourier series. Exponential Fourier series directly, magnitude and phase spectrum. So trigonometric formula and exponential formula are very important. Okay, do the problems on trigonometric and exponential. Okay, and after that you can write magnitude and spectrum. Okay, so this class is completed.
Thank you, sir.
Okay, thank you. How many students are there? Oh, 4 students are there. Okay, good, very good.